Hello everyone, my name is Nicole Green, and in this lesson we'll be looking at linear differential equations and we'll be focusing on exponentials. So we're looking at exponential functions as particular integrals. So in this case, we're going to start off with an example. So let's say we have d squared y over dx squared minus 7 dy over dx. We're going to add it with plus 6y, and this is going to be equals to e to the 2x, right? So remember, what we need to do is that we need to find its complementary function. To find its complementary function, we're going to put this in its d operator form. So realize that we're not working with a 0 on the right hand side, right? So now we're going to have d squared y minus 7 dy plus 6y is equals to e to the 2x. Remember that what we always do is to factor out the y, seeing that it is common between all of them. So we're left with d squared minus 7d. We have our plus 6, and we have our y on the outside. And this is going to be equals to e to the 2x. Remember that we need to change this into m to find its complementary. Well, what we need to do is change it to its auxiliary equation. To change this, we change the d to m and equate it to 0. So we have m squared minus 7m plus 6, and this is equals to 0. What we need to do is to find m. We could actually use method of factorization. So if we say there's an imaginary 1 here, so it's 1 multiplied by 6, which is 6. And then we need two numbers that multiply to get 6 and add to get minus 7. So we could use minus 6 and minus 1. So now we're going to have m squared minus 6m minus m plus 6, and this is equals to 0. So I just want to erase this. So I'm going to work from here. And what we need to do is that we need to factor out m for this side. So all we're doing is trying to solve for m. So now we're going to have m, open brackets, m minus 6. We have a minus 1, m minus 6. And this is equals to 0. So what we have now is that we have m minus 1 in bracket and m minus 6, and this is going to be equals to 0. So then we're going to equate the terms. So it's m minus 1 is equals to 0, and we're going to have m minus 6, and this now is going to be equals to 0. So what we're saying is that m is going to be equals to positive 1, and m here is going to be equals to positive 6. So we realize that we actually have two values for m. And in this case, m is equals to negative 1, and m is equals to 1, and m is equals to 6. So if you actually look at it, realize that these are real and distinct roots. So to find YC, remember the formula. So we're just going to put it in its formula. So it's C1 e to the x plus C2 e to the 6x. So this is our YC. Now what we need now is that we actually need to find YP. So we realize that over this side is not 0. So therefore there is an answer for YP, right? So how we find YP now? Let's draw a line here. So YP, what we do is that we're going to say 1 divided by what is inside the bracket here, which was already in its D operator form. So it's always 1 divided by what is inside the bracket here, which is D squared minus 7D plus 6. And we're going to multiply it by what is over the right hand side, which is e to the 2x. So e to the 2x. Now, as you could see, we're using exponential form. We're using exponential functions. So now how you could solve for YP, which is particular integral, is that we're going to do a direct substitution. So anytime you see e, an exponential by itself, what you're going to say is that d is equals to whatever is in front, whatever the power is above the e, which is the exponential, and we have it here as 2. So we're going to say is that d is equals to 2. So all you do is do a direct substitution for d. So if this was e to the 3x, you're going to say d is equals to 3. However, in this case, it's equals to 2. So that's what we're going to do, is to do a direct substitution. So we're going to have YP is equals to 1 divided by, so this is going to be 2 squared minus 7 times 2. It's 2 squared minus 7 multiplied by 2. And we're going to have plus 6 raised to the e to the 2x. Plus 6, and it's going to be raised to e to the 2x. It's going to be multiplied by e to the 2x. So what we have now is YP is equals to 1 over 2 squared is 4. So minus 8, and we're going to have plus 6. And this is raised to e to the 2x. So we're saying that YP is going to be equals to 1 over, so now 6 plus 4 is 10 minus 8, which is 2. So it's going to be a 2. So it's going to, the final answer for YP is a half e to the 2x. And remember, in order to find the solution, this general solution, it is y is equals to yc plus yp. So the final answer is y is equals to yc we had was c1 e to the x plus c2 e to the 6x. And then we're going to add it with yp, which is here, which is a half. And it's going to be raised to e to the 2x. And this is your final answer. We're going to do another example based on this. So let's say we have d squared y over dx squared minus 3 dy over dx. I'm going to add it to it plus 2y, and this is going to be equals to e to the x. So for this question, I only want to focus on how to find its particular integral, which is yp, right? So we know that this is going to be equals, putting its d operator form, this is d squared y minus 3 dy plus 2y, and this is going to be equals to e to the x. We're going to take out the d, so this is just going to be d squared minus 3d plus 2. We have a y on the outside, and this is going to be equals to e to the x. So remember previously, we're going to find yc, so we're just putting its auxiliary equation. So we're going to transfer the d to m and equate it to 0. However, what I want to focus on is how to find yp. So we already know to find yc, so I'm looking at yp. So remember, to find yp, if we have an exponential, which is e, it's going to be equal to whatever is inside the brackets. So it's going to be 1 over whatever inside the bracket. So we have d squared minus 3d plus 2, and it's going to be raised to e to the x. So remember, whatever is here, we're going to sub it for d. So what we're saying that is d is equals to 1. So we're going to have yp is equals to 1 divided by 1 squared minus 3 times 1. We're going to add plus 2, and it's going to be raised to e to the x. However, if you calculate the denominator, all of this is going to be equals to 0, because we have 2 plus 1, which is 3, minus 3. So we have 0 in the denominator. However, in this case, it is known as case of failure. So there, we need to take an approach, right? So the approach in which what we do is that we're going to have yp is equals to, we're going to differentiate the denominator. So once you have a 0, it's known as case of failure. So what we do is that we differentiate the denominator with respect to, so yeah, so we're going to differentiate the denominator. So we're going to have 1 over, differentiate this, you drop down the power. So it's going to be 2d minus 3. And we're going to have e to the x still. And then we're going to multiply by an x. So I'm just going to put an x here. So all you do, if you have a case of failure, you differentiate the denominator, write back whatever this is, and then multiply it by an x, right? So our answer for yp is going to be equals to x multiplied by 1 over, remember that d is equals to 1 because we have a 1 here. So we're just going to do the direct substitution now. So it's 2 times 1 minus 3 of e to the x. So our final answer for yp is going to be equals to x e to the x divided by minus 1. And this can be even simplified more. So yp is equals to minus x e to the x. So this is how you get your answer for yp. And to find its general solution, it's yc plus yp. So all you do is to find yc here.